do the
Okay.
thing.
Yep. So, physics problem. Huh? It's a wheel that's rolling without slipping. What's the speed after you pushed it? D. So, I went ahead here. Let me share my screen. Share. Cool.
So you don't want to wait for Chris or for Chris?
Well, he's offline, and I mean we gave him. He can show up if he wants to.
Okay.
Anyway, so I went ahead and drew a diagram. Took me a long time.
Mm-hmm.
Representing the situation. Put all the forces in. To solve this problem, well, I'm thinking energy principle.
For sure, yes.
And then assumptions, I just said no air resistance. I'm open to hearing other assumptions, like maybe we're not near a gravity well, so velocity is cool, not moving near the speed of light.
I said no slippage.
No slippage.
Yeah.
Like on the bottom of the wheel.
That's a good one. So, system is the wheel, surroundings, ground, and you. For the how do we solve the problem? Oh, just got a thing. Oh, they just remind us about the problem quiz. Cool. That's tomorrow. Yay. Anyway. So we could do a point particle system because we could.
I mean, that's the easiest way to go. I would.
Mm-hmm. But at the end, I was about to do point particle, but it says hint rolling without slipping means velocity times the angular speed.
Yeah.
I used that in the second part of the problem.
Second part was part 2.
Yeah, there's a part 2. I didn't use it in the first part. I just solved for velocity. I put 1/2 mv squared equal to force times displacement, which is just d, I think, in this problem.
Oh yeah, they gave us that hint twice. Cool. So, yeah. Two force distance divided by equals. Do we get real numbers for this?
No.
So what? 2 force distance over mass.
Yeah, square root.
Cool. Magnitude of the friction force.
Oh, energy principle again. Same assumptions. Same system and surroundings, but this time we're using an extended system. So then you have your translational energy and your rotational energy equal to work. And the main difference is that force is F net, so it's just force applied minus force of friction.
Okay. Okay. squared plus 1/2 mr squared omega squared Ooh, okay.
I just got FD minus K minus all of the kinetic energies. I don't know if that. Does it say what we can put our answer in, like what terms we can put it in?
No.
So I'm just gonna leave it as minus 1/2. I guess we could put it in since they give us the fact that velocity or like center of mass velocity is equal to angular velocity times radius.
What did you get? Like the friction force equals force times distance minus mr squared or w squared?
Wait, say that again?
Force times distance minus mr squared omega squared. Or what is that? Force distance minus mv squared.
I can't actually see your screen right now. It's just
Can't?
loading.
Still loading? Can everyone see my screen?
Yeah.
Yeah.
Cool. I can, you know what? Easy fix to this. Here we go.
By the way, Windows Shift S works also
For what?
for snipping tool.
What the poop?
It's really quick and then it saves to your clipboard.
Interesting.
That's a good picture.
Thanks.
Yeah.
I'm gonna paste it. I can't paste it? You lied to me. I can't paste
It
it.
said save to clipboard.
I literally cannot paste it. Select here to...
Dude. You're trying to do it into an equation, see if like click out of it.
That's cool.
There you go.
Cool.
Wait, oh my gosh, you just pasted that like a million times. Can you hear me?
Mm-hmm.
Yeah.
Okay.
Wait,
Cool.
no.
Hey
Thank you.
now.
What?
Your force, it's your net force dot your displacement. So F of friction also needs to be multiplied by D. So what your answer is, that is correct. You just have to divide the whole thing by D.
Bruh. Okay. God, gotta make me go through and divide everything. Cool.
This is a good question. So, for like part one, when we use just the point particle system and we do force times the displacement, it's the displacement of the center of mass. So, are we just assuming that's just D? We're not, because I mean, it doesn't really. I guess they're the same. Like when we're
Hey,
talking.
guys.
Okay.
Are you talking about the force that it's working through?
Like like I'm trying to sort through like the displacement for like a point particle system and the displacement in an extended system, because in this case it doesn't really give you. It gives you one
Yeah.
distance.
Yeah. So if it gives you one distance, I think the assumption is that your force is going to be working through the whole distance. I'm pretty sure. I don't know if it says it's a constant force or not, but um your force is going to be working through the entire distance. So the main difference between the point particle system and the extended system, the point particle, it's just from like point A to point B is the distance your center of mass moves, whereas in an extended system, you can have multiple forces acting on the system. So you have to add all of those different forces. And so like this force is moving right a distance d, but if you have another force, you would have to add that force, like say you have a force pushing back going left. You would have to
Like
add
on
those two
different points of
forces.
the wheel.
Yeah, on different points of the wheel.
Okay.
Like this is not a very good example of it, but like the ones where you have like a string
Yeah,
coming
like
out
the
of like
distance
a
of like you're saying like the distance from the center of mass is different from the distance of like let's say a block actually moving, the actual physical block moving a distance over. Like the displacements are different.
kind of. So it's like if your force can be moving, like your force can be working through a certain distance, like the string problems are a really good example of like if you have a box and you're pulling a string but
Oh.
some of the string is being let out. So the amount the string is being let out plus the distance the whole box moves is how much work your force is going through. Whereas the distance for the point particle system would just be the distance the box moves.
Okay. Okay. Got it. Got it. Got it. Got it.
Yeah.
So are we assuming? Did we say there's no friction in this? Is there friction for part two?
Well,
We're trying-
we're trying to find the friction.
No. Okay. I'm sorry. I'm trying to figure things out. Okay. Yes. Okay.
So, just want to say, the force, okay, so at the bottom, the net force is 0. It's because the force of friction is equal to the velocity. Do we overcomplicate this or complicate it the right amount?
I don't think that's true.
I don't think that part matters for this specific question. Are you talking about how at the bottom of the wheel the velocity is 0?
Give me a second. Alright, I'm back. Okay, so how confident are we in these answers?
Very
What-
unconfident.
Unconfident.
Is unconfident a word?
Mm,
What are we looking for?
Yeah.
Well, I mean, according to this document. Wait, what does this mean? Like, how do we know? How do we measure confidence? Like, what is this for?
this is just like, did they give us an easy problem or a hard problem?
Oh, it's like they can for next semester.
I think they're looking, well, even in this semester, I think they're looking for is very confidence and slightly confidence. If they get slightly unconfident answers and very unconfident answers, that shows that they need to change something about either their teaching style or the recitations.
Makes sense.
Mm-hmm.
Like, I got the same answer as you, except I substituted the r squared, w squared. I made that velocity of the center mass squared.
Mm-hmm.
So it's the same answer, just substituted some values.
Mm-hmm.
Perfect.
I'm pretty confident in these, but pretty confident's not a thing, so I'll go slightly confident. Oh man.
Does your answer seem appropriate? Yeah.
It's pretty inappropriate.
What did you say for that part? I got like the. I'm just gonna be like, yeah. Can you take that if
Yeah.
I just write yeah?
Yeah.
Different context.
I hate that they asked us that.
Ayush, you said you were unconfident about these answers.
Oh, that was a joke.
Oh, cool.
I am. So for that question you made though, what do you mean by ending height of 0?
Oh, for this? Oh, just
Yeah.
like when the cylinder finishes, like, well, like,
Oh,
when,
oh,
just
okay.
what
Sorry, I
you're,
thought you meant the dimensions of the cylinder.
no.
Okay. And then this is like the same thing again from last time.
Except this one has the extra balls on the side.
And it has a disc.
Wait, that's gonna be weird.
No, you just add
How
them.
does that work?
Pretty sure you just add them.
This one.
Okay, so principles.
So we are
energy
solving
control.
this? I guess we should just solve it. 'Cause
Yeah, I'd be down to solve it. Yeah.
Yeah, we'll do it.
Whatever. Okay. What is...
Okay, so translational energy is just work done. So
Okay.
so that's just gonna be the work done by gravity, and then the work is just wait, it's not actually moving, is it?
It's going downwards.
You pull the string straight up with constant force.
So would it be f of h minus f of g, so the displacement for the force for the point particle would just be h, right? F times h.
Mm-hmm.
Yeah, so
Well,
it's
it'd be
F
mass
times
gravity.
H.
Yeah, minus the mass times gravity for the force of gravity, right?
So for this problem, the string actually isn't, it's not moving the center of mass.
Why do you say that?
Because the force is acting... looking at it, it looks like the force is entirely rotational. From the string at least. Because the string is, I guess, I mean, I want to say perpendicular to, or tangent to the, completely tangent to the, whatever it's called, the disk.
But I mean, it's saying the apparatus is moving downward a distance h.
Mass times gravity times h.
But then wouldn't you have to subtract because if you apply enough force, it's gonna move up instead of down. So don't you just have to subtract the force that you're applying, even though it is, because it could be translational.
I don't think it is. I'm gonna double check that. Give me 20 seconds.
Because this makes me think of like a yo-yo, just with like rods sticking out of it.
Yeah, but I don't think the string is wrapped though. So it's just gonna like go
It says
down.
wrapped. A string is wrapped around a uniform
Oh,
disc
it
of
is.
mass m and radius r.
So it's like a yo-yo. Like if you pull it fast enough, like there's going to be string coming out of it, but you can still make it move upwards.
Yeah.
So I think you have to subtract the constant force. So it would be mgh minus fh.
Wait, but then what about the balls like on the side of it?
That is only included for
Rotation.
rotation. Yeah.
Because I was thinking, is it the force times h minus mgh? Because you're pulling the force, and it's causing the apparatus to move downward.
The work of gravity is going to be positive because it's moving downward.
Oh.
So it's going to be gravity minus force. I'm just not sure. I think force might be times L, not H.
But that would be when talking about the extended, because you're talking about the work in which a force moves, and that is moving L.
Right.
The force is moving
You're
L
right.
through a distance L. So
it would be H. It would be mgh minus fh. Right?
I mean, I agree with that.
Okay.
Any other thoughts?
We're waiting to hear back from Eric, who is either talking to his roommate or really Googling something intensely. I feel like there was a question like this on the practice exam.
Yes. I think so.
And it was question number 20. And I got it wrong. Amazing. Okay. So I know how to do the extended system portion of it.
That's the part where I am kind of, because I don't know how, because I know those masses that stick out on the sides, like that involves in rotational. I just don't know how, if you're just adding them together or what you do. But
yeah, basically, so what you do is you your you have two separate moments of inertia. Since you have a disk, you're gonna have your moment of inertia
of the
just
disc.
for the disk,
Mm-hmm.
and then you add the moment of inertia for all of them, like for all of the small
all the masses. Okay.
So you can just do 4 times one of the small masses, and then add that to the disk.
Got it. Okay.
Yeah.
And is that inertia, so doing like, is it 1/2, so rotational is 1/2 I W squared. Is it 1/2 I of the disk plus the I of the point masses times, like that in parentheses W squared, like you're adding the two inertias and you're multiplying it by the speed squared, angular speed squared? I don't know if that makes sense.
Yeah. It doesn't matter if you write it. I normally write it as 2 separate rotational energy,
Okay. Mm-hmm.
but it doesn't matter. Like it's gonna, they equal the same thing.
Okay.
So you can definitely write it as just 2 different moments of inertia added together. That actually might be easier. Save your hand from writing. Hair is greasy. Sorry. Oh my gosh. I'm sorry, guys. I was told that I look like a basic white bitch today, and honestly,
Oof.
I'm okay with it. My friend was like, "You're wearing white tennis shoes, legging, and your hair in a messy bun." He was like, "You're a basic white bitch," and I was like, "You know what? So what if I am?" I'm like, "We all knew I was a basic white bitch before this happened."
I
So
mean,
you might as well.
some people don't take it as an insult. Some people just like embrace that. Other people are like, I'm offended. So it's just who you are as a person, I guess.
Exactly. You know, why be offended? I'm one of those, like, I fit like the lazy girl personality. What's wrong with that? I don't like wearing jeans. I'm sorry. They're the least comfortable pair of pants that I own. Like, sweatpants and leggings for the win, my man.
But leggings make me cold. Like out in the winter, like they don't. To me, they don't keep you very warm. They're comfortable, but they don't keep you very warm.
Do you wear jeans in the winter?
I mean, honestly, I'll wear jeans whenever, but it's just whatever I'm in the mood for, basically. Wait, do you have Birkenstocks? Do you own a pair of Birkenstocks?
I own a pair, but they are like I don't wear them. My sister
Mhm.
wears them, but I originally bought them because I was told they would help keep my feet aligned or something like that.
Hmm.
This was back when it was for for posture,
Huh.
and now everyone wears them. Do you wear Birkenstocks?
No, I do not own a pair of Birkenstocks, and I will never will.
Yeah. I was told they were super comfortable, and then they weren't, and then now my sister wears them, so I'm like, okay, this is fine. I just prefer tennis shoes. Like I wear tennis shoes every single day, unless I'm wearing boots because it's raining. That is the only time I don't wear tennis shoes. I can't do like flip flops or anything either.
Hmm.
I just think they're gross. All right, Eric, you're
I
back.
saw movement. Is
I
he here?
know. We've come to a consensus, but you are free to tell us if we're wrong. He's still non-responsive.
Muted.
I'm gonna
perhaps?
pretend. Yeah. I'm gonna pretend his roommate's there. Hi, Eric's roommate. How are you? Wow. He must not be there. That's unfortunate. Is
Okay.
Ayush still there?
Hey, wait, what did you
Yeah.
what'd you guys do at this point? Sorry.
We were just saying hi to your roommate.
Oh.
We
He
can't.
he couldn't
I
hear
think
you.
he wears headphones.
Oh.
Oh yeah, I do.
Ayush, you just sat there and let me look like a fool.
I'm sorry. I didn't want
Okay,
nothing.
so
Okay, so Eric,
mm-hmm.
we decided that translational kinetic energy is equal to mgh minus f of h. What did you discover?
F of H.
Or f8, not f of h, but like f8 times
Yeah,
h.
F times H. That I think I disagree with that. So what?
Okay, go ahead.
Well, because the force isn't acting on distance h.
We discussed that, but we think that's the extended system. We're using the force as we're just doing like mg minus f. So it's just the net force times the height, which is times the displacement, which is h. So like you're thinking of it in an extended system, and we're thinking of it in a point particle system.
What you could also do is you could well, so I was trying to get it to be a point particle system, but let's just say let's fully commit to this extended system. So our net force is force times L minus mgh. That's our net force on the entire system, and that is going to be equal to we have our angular. We have rotational kinetic plus our translational plus, oh gosh, do we need to think about potential?
Oh, no, because we include
Yeah.
that in our work.
Oh, duh. Yeah, you're right. Cool. So if we do this, we know what the rotational is. It's 1/2 times m times whatever I square is. They gave it to us times the.
You mean I omega squared?
Yeah.
Well, yeah. Also, wouldn't it be mgh minus fl because work is going to be positive, or like the work of gravity is going to be positive? Since it's
What?
going down. Because force and displacement, yeah. Did that make any sense? Because the force of gravity is going downward and the system is going downward, so the work of gravity is going to be
Oh.
positive.
Okay.
So,
Sure.
except and that's, yeah, there we go.
I dig. So that would mean that A trans equals mgh minus mass times, what is this? m squared, so we have mr squared. Oh, shoot.
What part 2 is, though? And I think they want us to use a point particle system for this part.
I think they want us to use. God, I got an email. Didn't we?
Because whenever you find the translational energy, you always put it equal. You always use the. You put it equal to the work. In a point particle system. Like, that's how we've set up, like, all of the problems in the past.
Yeah, because we need to find the angular speed in the next, and we don't have the angular speed right now. God dang it. Okay, alright, this. Do we have, like, lectures or something that we can steal concepts from?
Low-key, I think we've done this problem before. I know how to do the second part, because that was on the practice quiz, or practice exam.
Yeah.
What is... This is... I know we've done a question exactly like this before.
I mean, yeah, all of these questions look the same.
That is accurate.
Maybe
Sorry.
you do have to do point particle to like.
I think you do because you don't have the angular speed. And if you don't have the angular speed, you can't. Then you don't have the rotational kinetic energy.
So point particle just to get translational, and then you do the other one to get rotational.
Mm-hmm.
Okay,
Yeah.
I guess that makes sense. It's tricky because in my head I'm doing the entire process like I was taught with the torque to make sure it makes sense with the energy system like that, because we would never take that for granted.
Yeah.
That it wouldn't do anything to the point particle.
Mm-hmm.
And we never differentiated between the two, like, energy modes or whatever, because
Yeah.
it didn't really make sense.
I want to say every time I've done this problem, I've set the point particle work to be mass gravity height, but I'm not 100% sure, which is frustrating.
You and your roommate are both very smart, and I think it's really fun. You guys must have a lot of fun.
We do have a lot of fun.
I'm gonna Google it.
Oh, trust me, that was step 1 for me. If you can find whatever I missed.
Chegg. Yes. Okay.
Are we just not knowing like what what to set the work equal to? Because we're debating about what is the displacement that the force is acting through for the point particle system.
Well, and through that, what the force is.
Yeah, so because all of the questions that we do that are like this are horizontal and not vertical, I feel like.
There was one problem that was a yo-yo problem. Let me...
I'm trying to find it.
Following yo-yo. For the following yo-yo, they use a point particle system.
16.
It was the force of the Fs. Is it a spring? Oh, force of the string minus the force of gravity.
Times how much the yo-yo fell, which was 0.4 in the example.
But it was negative 0.4 because it was going down.
Yeah.
So we already
Okay.
did that.
So what you
Yeah.
guys said with the forces times the height. Okay.
Yes.
Yay!
Okay.
Team 44 power.
I'm right for once. Yay!
I really hope that's me on the exam. Be like, oh, I'm right? Yes, please.
I hope so. I'm feeling better about this exam than I was my last exam, so there's
Really?
comfort in that. Yes.
I'm not. But that's okay. It'll probably be fine. That's what I keep telling myself, especially because I don't want to study at all this weekend. So I'm trying to cram all my studying into today and tomorrow. But that's fine. Because we're smart students here.
Sorry, I thought I was muted. No, I'm just kidding.
Right. I'm just sitting over here eating my hot Cheetos. It's fine.
This class. Okay. M times.
You guys are the only reason I missed this class, I'm not gonna lie.
The only reason that you what?
That I'm gonna miss this class.
Oh, yeah.
I feel touched.
Honestly, our weekly meetings make this whole class worth it for me. If I was doing all of this by myself, low-key, would have dropped out of college by now.
Yeah, this class is terrible.
That's facts.
Okay. So it's that. Rotational. By the way, the lecture for this is oh shoot. Parker.
Parker is a quality name.
Peter
I know it's
Parker.
That's not what I thought, but that just makes it even better. Oh my gosh. Amazing.
Wait, what'd you say?
I said Parker is a quality name.
Oh. Yeah.
Why do they keep making us write all of the stupid principles and assumptions? And I'm just gonna say same. I'm tired of this. And I keep messing up my numbers. 2, 3. Same. Alrighty. Let's solve the extended system.
Mhm.
Beautiful. Okay.
All right, let's hurry up. Apparently there's some apple cider happening on my floor, so I'm gonna need to very
Okay.
quickly.
Okay, so we have the translational plus the rotational is equal to the work, which is going to be the, now this one is MGH minus FL. And so just plug in what we found for translational, MGH minus FH plus 1/2 I omega squared equals MGH. I'm sorry, if you want me to shut up, please let me know.
Why would the force for the second part be negative? Like, wouldn't it be positive? Because L is going up, and the force is going up. So, wouldn't
Wait.
it be MGH plus FL?
Why are you talking to me?
I'm talking to anybody.
For translational or for work? For work, it's
Work
yeah, MGH
and
plus.
extended.
I was doing.
Wait, what is going on here?
I was
Where's
gonna.
your rotational energy?
Me?
Yeah.
Still writing. 2 mass r squared. Don't look. Squared. There we go. That's my rotational. Because the rotational is going to be the disk plus the 4 masses. And r is b.
Plus.
So it's mr squared plus 2b squared. Force of gravity. It's mgh. And the total.
Oh wait, there's like big R and little r. Yeah, okay.
So the yeah, would be mgh plus FL. One-fourth m.
Question, wouldn't it be, since they're point particles, it's gonna be... Never mind.
Question answer.
I didn't realize you'd already distributed your 1/2. That's not.
Sorry, why am I doing mgh twice? Omega squared equals FL plus FH.
What'd you get? Okay, one bit taco. Yum.
Yum indeed.
Huh? We're out of beef? Sorry, I'm talking like... Oh, well, yeah, but look at you went so late. How is Walmart? Quality check.
Wait, how come?
Did I do it wrong?
No, I just have a question about. So you have 2mb
Oh.
squared, omega squared.
Uh-huh.
What are the two? Why is there only a 2 and not a 4?
One
That's my
ha-
only question.
It's 1/2 times I.
Oh,
Or-
okay. Yep. Mm-hmm.
Wait, you lost
right.
your 2b squared for For
I.
B.
Yeah, you're right.
so that's 8.
8, yeah.
B.
You are correct. Thank you.
I got you. And it's not M's are not the same, so you have to keep your big M and your little m separate.
And
So
oh shoot. What is the entire thing? M. Oh, right.
so big M just goes with R and little m just goes with B.
So
There you go.
we're gonna have to do a lot of M plus M's. Big M goes with R?
Yeah, big M goes with R. Little m goes with B. Perfect.
So when it's MGH, it's really M plus MGH.
Yeah. I think it would be M plus 4M, but I don't think it really. I mean, those cancel, so it doesn't really matter.
No, it does. 'Cause that's the translational. God. Alright. I'm gonna leave it factored.
Wait, that is technically not the same answer.
What did I get? What did I do wrong?
Because if you're multiplying those two, if you multiply like the denominator out, that's not going to get you the same answer as because it's just big M R squared plus 8 little m B squared.
Oh, whoops. Yeah, you're right. Thanks. My brain's dead.
It's okay, me too. I've literally been studying for this class all day long.
Wait, there was no mass there to begin with.
That's because you had them cancel when you had them all as little m.
Oh gosh.
So your moments of inertia all need m's.
Oh
Yeah.
gosh.
And then the rest of that looks right, except yeah, there you go.
Okay. This is what you got?
Yes.
I'm totally just taking your word for this.
It looks good to me, I don't know.
Is this at least what everyone else got?
Checking.
I just moved it to the other side.
Where did the 8 come from and the MB squared?
4. Oh, I took out a 1/4. Because it felt like it.
Because there's a 4 in the numerator, so when you if you put the 4 in the denominator, it would change it to 2.
I mean, I suppose
Oh,
we could,
okay. Big brain. Okay.
I suppose we could
got
do
it.
this. 1/4, and then 2, because I mean it's the same
Yeah,
thing.
it's the same thing.
I feel so much better now. That's great.
What was I gonna say? What assumptions, approximations do you need? I just put no.
I just put same as always. And then I said except now it's an extended system.
Yeah, same. Yeah.
We could justify again.
I'm saying like the exact same thing.
I don't know. I'm just putting junk down. I don't even know if they read these.
I don't think they do. We know they don't listen to the videos. So.
I feel like one day we're gonna say that, and then like they're gonna be like sifting through the video, and that's like the one thing they hear.
I mean, what are they gonna do if they're gonna be like, actually, we do
Expel
listen
us.
to Expel us. Do it. Honestly, then I can go live out my dream of becoming a Sherpa. I would not be a Sherpa. I think I would be really good at it. Are you kidding me? I can talk so much. I could talk about the mountains all day long. Not walk through the mountains all day long. Okay, so I would be a good tour guide somewhere besides the mountains. Where you could sit like in the bus. I don't want to sit in a bus. I think I'm a fairly fit person. Maybe not.
Yeah.
Are
Okay.
you kidding me? People pay to